The third film in this series is about so-called instrumentation amplifiers. And of course they are very popular within instrumentation. So what we have there is that you have a pre-made amplifier again, and inside there you will actually find three op-amps, three normal op-amps connected with a number of resistors. So that will form some kind of equation there where the overall amplification or the overall V out is controlled by some internal resistance that we can do nothing about. It's pre-made from the factory, but you can connect your own resistor RG, and by that control the overall gain of this amplifier. It's a differential amplifier, which means that it amplifies the difference between two signals, plus and minus. So, for example, if we have a circuit like a bridge, for example, a Whetstone bridge, like that, remember that from last week, and you want to amplify the signal that you measure between A and B, you use an instrumentation amplifier, and you take the signal from point B and the signal from point A, and you connect that, for example, to here, A and B. So you connect that to your instrumentation amplifier and adjust the overall gain by simply adding one resistor. Also, for the instrumentation amplifier, same as with the normal operational amplifier, is that there is no current going into the terminals. So the current into the terminals is basically zero, but still we are of course able to measure a voltage, for example here in the bridge. So there's virtually no current drawn from the input terminals, so you can have a sensor, a deflection bridge or something connected to the terminals without disturbing the signal in the bridge. So you're not unbalancing the bridge, for example, by connecting an instrumentation amplifier. They have excellent stability and accuracy, so they are very accurate instruments, and you only need one resistor to specify the gain, and that is the one here, RG. So a typical number for an instrumentation amplifier named AD620, which will cost you about 10 kroner or €1. That amplifier has the internal resistor, not RG, R internal, of 49.4 kilo ohms. So if you, for example, here connect that with an RG that is 4.94 kilo ohms, and you know from the datasheet that the internal is 49.4 kilo ohms, you will get the fraction here becomes 10 plus 1, so the overall gain is 11. So the difference between the two inputs here is multiplied by a factor 11. And as shown earlier, by having an instrumentation amplifier without input currents going into the terminals, circuit number 2 here can collect data from circuit number 1 without disturbing circuit number 1. Here's another example. If you have the internal resistor 49.4 kilo ohms, you want to select an RG that gives us a gain of 10. You want gain of 10, so this one should be 10, and you set RG on one side of the equation, and that will become 49.4 kilo ohms divided by A minus 1, which is 9, because you have 10 minus 1, and that will give you 5.44 kilo ohms. So if you here connect a resistor of 5.44 kilo ohms, that will give you an overall gain of 10.